In this video, I'll be showing you how to do sine rule, cos rule, and area rule for grade 11 level. It's important to note that in grade 11, you have to work out sides and angles of triangles that are not right angled, whereas in grade 10, you had to use right angled triangles only. So the first rule to do this is sine rule. And we use this base triangle to show the different rules and represent them. What's important about this triangle is that the labeling is very important. So the angles have capital letters, whereas the side lengths have small letters. And you'll notice that the angle name, capital A there for example, sits opposite the side that we label as small a. Likewise, angle B sits opposite side B. And of course, angle C sits opposite side C. The formula then is derived from taking sine of angle A over side angle A equals sine of angle B over side B equals sine of angle C over side C. This formula can be written in the reverse as well, where you have the side at the top and the angle at the bottom. It doesn't matter which side you use, which formula you use. What matters is that all the signs are on the same level, the angles, and all the sides are on the same length, on the same side of the fraction. It doesn't matter which one you choose, you'll get to the same answer. In these questions, we also only usually work with two of them. So in these questions, you'll be given 3 pieces of a 4-piece puzzle, and you have to work out the final piece. So for example, you would be given angle A, angle B, and side A, and you have to work out side B. Okay, so that is sine rule. Next is cos rule. Cos rule works with the same triangle, except there's a bit of a difference. For cos rule, the formula is a squared equals b squared plus c squared minus 2bc times cos a. You can see most of these variables then in this equation are side lengths. So you can see we square side A and we make it equal to b squared, which is over there, and there's another b there in the formula, and there's a c, and there's another c there, and then cos A of that angle. Essential to cos rule is the relation between all of these different pieces. Cos A has to be, or angle A has to be the angle between the two lines that we are working with on the right hand side of the formula, B and C, and side A has to be the side that sits opposite angle A. There is no other way to do the cos rule. It has to be such that a squared, the a value or the a side, sits opposite the angle that we are applying cos onto. So usually in these questions, what we say is that angle A is included in the two sides, meaning angle A sits between these two purple sides that we're working with. So that's how you recognize it as cos rule. Next is area rule. So it's important to know, similar to cos rule, that side B and side C have to sit up and make angle A, just like in cos rule. So the angle has to be included in the two sides that we are putting into the formula. So that angle A sits between side C and side B. Side C and side B meet to make angle A. And the formula is a half BC, so those two included sides, times sine of angle A. So this formula can logically be written a different way if we're working from a different perspective. So for example, if we're working from angle C, then that becomes the critical point, and we're working with the two sides that meet to make it. So then the formula could be rewritten as area equals half A, the one side, times B, the other side, times sine of that angle that we're working with, C. And then of course you could do this again. You could rewrite this formula working with angle B. So then you would have area equals to half A times C times sine of B. So it's not so much about labeling things exactly as A, B, and C. It's more about the relation between the specific sides and angle that we are working with. Let's move on to some examples. In this example, it says calculate the length of JK as well as the area of the triangle. So we'll start with the length of JK. So let's look what we have in this diagram. We have a 12 for JL, and we have angles of 60 and 50. So we can see already that angle K, 60, sits opposite this side, and we are trying to work out JK, but we've got that 50 degrees, which is opposite. So this is an opposite situation happening. So this probably means we're going to need sine rule, because we have an opposite happening there, an angle and a side, and we have an opposite happening there, where we've got an angle and we're working either side. So we have 3 pieces for a 4-piece puzzle. So let's work this out. So I'm going to rewrite the formula first in terms of the diagram. So sine of K over JL equals sine of 50 degrees, or angle L, over JK. I could have written the sine 50 as sine of L, because that's the angle. Then we substitute everything in that we know in the next step. So sine of 60 over JL, which is 12, equals sine of 50 over JK, which is what we don't know. So now we need to solve for JK. So when you have these two fractions equaling, you can cross multiply. So JK times sine 60 and 12 times sine 50. So that's the next step. So JK times sine of 60 equals to 12 sine 50. We want to get JK by itself, so we divide both sides by sine of 60. And then we have JK equaling 12 sine 50 over sine 60. And that's when you can put this into your calculator, and you will get 10,61 units. So that's the length of JK. So I'm going to fill that in on the diagram, 10.61. Okay, so now we have to work out the area of the triangle. But if you look, we don't have But if you look, we don't have two sides that meet at an angle. We only have side 12 and side 10.61, and the angle that they meet at, we don't know. But because it's a triangle and we have two of the other known angles, we can work it out. So angle J is equal to 180 minus 60 minus 50, which gives you 70 degrees. So this angle J is 70 degrees. And now we have the two sides that meet to form that angle, so we can use the area formula. So area is equal to half of the one side, which is JK, times half of the other side, JL, times sine of the angle, which is J. So area equals a half of 10.61 times 12 times sine of 70. And if you put that onto your calculator, you will get 59.82 units squared. And that's your answer. Another example. Calculate the length of TS and then calculate the angle, the size of angle S. Okay, so let's look at what we've been given in this diagram. So we have two sides that we can see visually meet to form an angle. So we have PT and PS that meet to form that angle of 40 degrees. So this means we use cos rule because we are trying to work out side TS. So let's write this out. In terms of this diagram, TS squared, the side opposite the angle we're applying cos on, equals PT squared plus PS squared minus 2 PT times PS times cos of our angle, which is angle P. Now let's substitute. TS we don't know. PT is 10 squared plus PS 12 squared minus 2 times both of those values times cos 40. If you put this into your calculator, 60.15 centimeters, and remember now that this needs to be square rooted because we want TS by itself. So if you square root that, you will then get 7.76 centimeters. So TS equals 7.76 centimeters. Then they're asking to calculate the size of angle S. So the way that I'm going to do to calculate the size of angle S is cos rule. You can use sine rule because we do have side TS, which is opposite angle P, which we know, and we're working out angle S, which is opposite another known side of PT. So you can use sine rule, but you can also use cos rule because we have all the relevant pieces. We have two sides that meet to make the angle, which we'll apply cos on, and we have the opposite side of the angle we are applying in this formula. So I'm just going to show you the cos rule way, just so that I can show you that this cos rule works and we can find an angle using the cos rule as well, and not just a side length. Okay, so let's write this out in terms of the cos rule. It would be pt squared equals ps squared plus ts squared, our two sides, minus 2 times those two sides, times cos of s, which is what we're looking for. Let's substitute in 10 squared for pt equals ps squared, 12 squared, plus 7.76 squared, minus 2 times those two values, times cos s, which we don't know. That's what we're working out. Now we can simplify. You should get on this right hand side, this piece simplifies to 204,2176 minus 186,24 cos s. Now what we need to do is take over that 204,2176 to the left hand side and minus it. You get minus 104.2176 equals negative 186,24 cos s. What we want to do now is get cos s by itself. So we divide both sides by the coefficient of cos s, which is minus 186,24. So that would equal to 1357 over 2425 equals cos s. Okay, now we can put this into our calculator using shift cos, and we put that fraction into the bracket. Therefore, angle S is equal to 55,93 degrees. And that's your answer. If you use sine rule, you might have got a slightly different answer for the second decimal place, but that's just to do with rounding.